Welcome to this lecture on peripherals and networking hardware, where we'll unpack how devices connect, communicate, and scale. This opening slide sets the scene with a visual of keyboards, servers, and network diagrams to remind us that today's systems blend many interfaces, protocols, and power considerations, and we'll explore how these pieces fit together to deliver reliable desktop and data center experiences. This slide traces the evolution from legacy PCI to AGP and modern PCI Express, showing how the industry moved from shared parallel buses to scalable, serial point-to-point lanes. The key idea is bandwidth and latency improvement. AGP-focused graphics, while PCIe offers lane scalability for GPUs, NVMe storage and high-speed networking, illustrated by the lane and bandwidth diagrams comparing X1 through X16 configurations. The USB evolution slide highlights connector and speed milestones, from USB-A and Mini to USB-C, and from USB 1.1's low rates to USB 4's multi-gigabit performance. It also introduces plug-and-play and power delivery, noting that USB-C PD can supply up to 100W or higher via extended specs, while the chart reminds us that higher power and speeds demand shielded cables and careful signal integrity management. This comparison looks at FireWire, USB, and older legacy ports, showing why USB achieved universal adoption while FireWire retained a niche. FireWire's peer-to-peer, isochronous design made it great for real-time audio and video, but USB's economies of scale drove mass-market growth. The diagram emphasizes that specialized, high-performance interfaces persist where professional AV and high-bandwidth applications require them. This survey of input and output peripherals explains how diverse sensors and devices, keyboards, mice, webcams, fingerprint readers are normalized through embedded controllers, configurable drivers, and OS-level APIs. The diagram maps device-specific formats into standardized interfaces like HEAD and USB, so the operating system can present consistent APIs to applications and route data to monitors, printers, speakers, and haptic motors. When comparing external storage solutions, the slide contrasts small, portable flash media with larger external HDD and SSD enclosures, highlighting trade-offs in portability, capacity, and backup focus. The visuals stress that interface choice, like USB or Thunderbolt, impact sustained transfer rates, while factors such as shock resistance and encryption options determine suitability for mobile or secure data workflows. This slide compares Ethernet and Wi-Fi NIC architectures, showing the common frame interface the OS sees and the different hardware duties behind it. Wired NICs emphasize auto-negotiation and checksum offload, while wireless NICs add radio, antenna diversity, and encryption hardware such as WPA accelerators. The takeaway is that both present a standardized frame API to the operating system despite very different underlying components. The cable types slide walks through twisted pair categories, fiber single, and multi-mode behavior, and coaxial remnants, using charts to link frequency, data rate, and distance. It points out RJ45 pinouts for gigabit links, explains how single-mode fiber travels far on one wavelength, while multi-mode relies on modal bouncing, and reminds us that impedance matching is crucial to avoid reflections on long runs. This driver stack slide explains how generic OS calls translate into device-specific actions through a layered driver model. It covers class, bus, and function drivers. The importance of signed and validated driver code for stability, and boot time enumeration and hot add flows that detect hardware and load resources. The slide also points to technician tools like Device Manager and LSPCI for diagnosing driver and firmware issues. The troubleshooting slide outlines a layered isolation approach for fault finding, moving from the physical layer port LEDs and cable continuity through data link tests like NIC loopbacks into system checks such as driver errors and SMART, storage diagnostics, and finally, application-level fixes like printhead cleaning. The flowchart emphasizes systematic, step-by-step diagnostics to pinpoint whether an issue is hardware, configuration, or software related. Exploring USB 4 and Thunderbolt, this slide shows how multiple protocols, PCI Express, DisplayPort, and USB, are converging over a single high-speed pipe to deliver up to 40 gigabits per second plus power. The visuals highlight new consumer board capabilities like eGPU support and faster wired networking, and point out a broader trend where peripherals are increasingly network attached, reducing local bus dependency and enabling flexible resource pooling. The final decision matrix helps future-proof peripheral choices by weighing criteria like bandwidth need, port availability, driver maturity, power budget, and security features. The recommended pre-purchase checks include verifying firmware update policies and confirming backward compatibility, because matching peripheral, network, and bus specifications thoughtfully yields scalable, resilient systems that remain useful as workloads and standards evolve.